In this section I'm going to show you the closer galaxies, one of which we live in, the Milky Way, and the large and small Magellanic clouds. The Milky Way is a barred spiral galaxy, 100,000 to 120,000 light years in diameter, containing 200 to 400 billion stars. The stars in the inner 10,000 light years are organized in a bulge and one or more bars. The solar system is located within the disk about 2/3 of the way out from the galactic center on the inner edge of a spiral concentration of gas and dust called the Orion Cygnus arm. The Milky Way is part of a local group of galaxies which form a subcomponent of the Vigoro supercluster. At least, the Milky Way contains at least 100 billion stars and may have up to 40 billion stars. At least 17 billion Earth-sized exoplanets are estimated to reside in the Milky Way. The stellar disk of the Milky Way is approximately 100,000 light years in diameter, but only 1,000 light years thick. Now, to help you visualize this, if this disk were reduced to 110 yards in diameter, just a little bit bigger than a football field, the solar system, including our Oort cloud, would be no more than 1 millimeter in width. That tiny. The nearest star, Proxima Centauri, would be 4 millimeters away. Another way to look at it, if the solar system out to Pluto were the size of a U.S. quarter, the diameter of the entire Milky Way disk would be approximately 1,200 miles in diameter, having roughly 1/3 the area of the United States. Surrounding the galactic disk is a spherical galactic halo of stars and globular clusters that extend out to, maybe 200,000 light years. They extend out as far as the large and small Magellanic cloud, and they come in and kind of keep these things from going any further out. It takes the solar system about 250 million years to complete one orbit around the galaxy. So the Sun is thought to have completed about 20 orbits during its lifetime. Now, even in my time in college, we realized that the galaxy was not rotating properly. If it were, the rotation speed of a star around the center would decrease with distance from the center. However, the observed curve is relatively flat, indicating there is additional mass that cannot be detected. This inconsistency is attributed to dark matter now. Back then in college we called it the missing mass. The previous pictures have been pictures of the Milky Way in our sky. These pictures are now sort of a map of the Milky Way put together such that this is what it would look like if it were flat in galactic coordinates. This is what the Milky Way looks like covering our entire sky in the microwave bands. This is what it looks like in the infrared, the whole sky. This is what it looks like in the radio spectrum at 408 megahertz. This is cold dust in part of the Milky Way's disk. Now this is called, the pink part here is called the Magellanic stream. The two brighter dots lower to the right are the large and small Magellanic clouds, but the pink streams are the gas that apparently the Milky Way is devouring another galaxy passed too close by, and we are consuming it. This is the only picture that I've got of both the large and small Magellanic clouds together. They're about 20 degrees apart in the sky in the southern hemisphere. Can't see them from the northern hemisphere. This is a small cloud of Magellan. It's called Magellan because he was the first captain that went down in his world round the world trip to see him. Kind of neat having a galaxy named after you. Anyhow, the small cloud spans about 15,000 light years and is about 200,000 light years away. In this last picture here, you see the globular clusters, which are closer. NGC 362 bottom right and 47 Turricane left, which are only 13,000 light years away. Now this is the large Magellanic Cloud. It's the fourth largest galaxy in the local group after the Andromeda Galaxy, the Milky Way, and the Triangulum Galaxy. The Large Magellanic Cloud lies about 160,000 light years away with a diameter of 14,000 light years. It's called an irregular galaxy for obvious reasons. The distance between the two small and large Magellanic Clouds is about 75,000 light years. Streams of neutral hydrogen connect them to the Milky Way and to each other. Their gravity has affected the Milky Way as well, distorting the outer parts of the galactic disk. Because of its encounter with the Milky Way compressing the gas in it, the Large Magellanic Cloud is a vast area of star-forming regions. All these little pink globs you've been seeing are all star-forming regions. This black and white picture here is taken in hydrogen alpha light. Those are hydrogen clouds that are collapsing to form stars. The next one there is in infrared light, showing all the gas and the dust. Like I said, there's lots of star-forming regions in the Large Magellanic Cloud. This one's called N11, and this next one is called the Seahorse. The pillars of smoky dust around 20 light years long. These three pictures here are of 30 Doradus in the Large Magellanic Cloud. This is a nebula near a hot, very, very unstable Wolf-Rayet star. This is called the Ghost Head Nebula, NGC 2080. It's about 50 light years across in the Large Magellanic Cloud. The next two are called N11, are these next two pictures. These next three pictures are all the same thing. They look differently just because they're processed a little bit differently. It's called N44. This one is N70, and then the next three pictures are N81. N132d is a supernova remnant in the Large Magellanic Cloud. N159 is called Papillion Nebula. And this one is star cluster is called R136. These next six pictures are of what's called the Tarantula Nebula. It's 1,000 light years in diameter in the Large Magellanic Cloud. Even though it's so far away, it still covers a field as wide as our full moon. That's pretty big considering how far it is away. Our Milky Way is just so huge and massive that other galaxies drift too close to us. We just rip them apart and eat them for lunch. The Sloan Digital Sky Survey found 8 new dwarf galaxies. Canis Major Dwarf Galaxy is getting ripped apart by the Milky Way. And this is what we think the Sagittarius dwarf tidal stream looks like going around the Milky Way as it's getting ripped apart. Now let's get back to our Milky Way galaxy. In fact, let's get back to the center of our Milky Way galaxy. The center of our Milky Way galaxy contains a black hole. We know this absolutely for sure. We can see the stars orbiting around it, which I'll show you later. This picture here is 34 by 20 degrees, showing the center of our galaxy. This shows an area 1.5 by 2.5 degrees wide. This is the central molecular zone area of the center of our galaxy, and this is the center of the galaxy in infrared. It's about 300 by 115 light years. This is the center 900 light years of the center of our galaxy. And these next two pictures are X-rays from our galactic core, showing 2 lobes on either side, probably jets being thrown out by the black hole. This is the galactic center radio arc. The structure at the bottom right surrounds a black hole at the galactic center and is known as Sagittarius A. Usually stars move around so slowly in our lifetimes you really can't see any movement. But here at the center of our galaxy, you see the stars orbiting around the black hole. You plot the orbits of these stars, you determine how big these orbits are, and the only thing with enough gravity that can fit in there and pull these stars around like this is a black hole. We have definitely discovered a black hole at the center of our galaxy.